So this next portion of the lesson, we're going to be looking specifically at the calculations now, calculating the VAR. So again, as we saw from the previous slide, the one-day value at risk is the expected one-day loss at a given confidence interval. And we're going to be learning how to calculate the value at risk now. The risk metrics model. So now we're moving into how do we do the calculation for the one-day value at risk. And so the couple of things up here is that recall two important things is number one, you can calculate the value at risk in terms of a dollar amount, or number two, you can calculate it as a percentage of the overall portfolio. So that was the important thing to remember. But quite often we're looking at the dollar amount. So this is why I put the big dollar signs. And so remember, there are three components that we need. One is the dollar market value of the position. And again, that's saying market value, not book value. So it's the dollar market value of the position times the price sensitivity of the position. And we're going to be looking at fixed income portfolio here. So we're using duration, modified duration. And the third component is the potential adverse move in yield. So because we're looking at fixed income portfolios, we're measuring that in terms of basis points. So again, since price sensitivity multiplied by adverse yield move measures the degree of price volatility of an asset, we can also write this equation as the one-day VAR equals the dollar market value of the position times the price volatility, and that's a percentage. So remember, we saw this previously, I started with it, but now we're reviewing it again, is that the price sensitivity of the position times by the potential adverse move in yield, that's how we calculate the price volatility, and that is given as a percentage. So quick review, the one-day value at risk is the dollar value of the position times by the price sensitivity of the position times the potential adverse move in yield, and price sensitivity of the position times the potential adverse move in the yield is that product equals the price volatility. Okay, so the one-day VAR is the dollar market value of the position times the price volatility in terms of percentage. So we can see here 1, 2, 3, 4. It's the classic type of math equation. Given three variables, can you calculate the fourth? Or down here, there's three variables. Given two, can you calculate the third? Or because this one is broken out into more components, it's always given two or three, solve for the unknown. So now we're moving up to the next level of understanding, focusing in on this price volatility. So recall the price volatility is the product of the price sensitivity of the position times the potential adverse move in yield. So the potential adverse move in yield, we're going to be given that in terms of basis points. So again, 20 basis points equals 0.002 because 100 basis points equals 1%, which equals 0.01. So that's something you need to remember. But now we're moving over here to this part of it, the price sensitivity of the position. We're measuring that in terms of modified duration. Okay, so the modified duration equals D divided by 1 plus R. What is D? That's duration. And what is R? R is the yield. We're going to see that on the next slide. But again, just to as a quick review, VAR equals the dollar value of the position times the price volatility. Or we can break that down to VAR equals the dollar value of the position times by modified duration times by the basis points. So again, here we can see 1, 2, 3 variables. Given 2, can we calculate the third? So when we're looking at the calculation problems with regards to the risk metrics model and calculating the VAR, we've got a number of different variables. We're going to be given some variables and we're going to be solving for the unknown. So when we're looking at formulas, we always like to look at, concrete example with real numbers, and this is straight out of the textbook. So if we look at, suppose a financial institution has a $1 million market value position in zero coupon bonds of 7 years to maturity with a face value of $1,631,483. So you can see the face value is not a nice round number, but nothing to be confused with that. And the market value is 1 million. So right now the zero coupon bonds are worth $1 million, and they're going to mature with a face value of $1.6 million. So today's yield on these bonds is 7.243% per year. These bonds are held as part of the trading portfolio. Thus, the modified duration of the bond, we need to calculate that, because as we know, when we calculate the dollar value of the bond, this is one of the components, the price sensitivity. So modified duration equals the duration over 1 plus R. So a quick note here I put in bold and green is that zero coupon bonds have a duration that is equal to the maturity. So we look up here, we can see that the bonds have a 7-year maturity, so the numerator is 7. And then in terms of the denominator, the R, that's coming from the yield of the 7.243%. So you can see 1 plus R is 1.07243. So in this case, the modified duration is 7 divided by 1.07243. So we're getting 6.527. Now we need that because, as we know, we're going to use that modified duration times by some change in the basis points in terms of the rates. So given that the yield on the bond is 7.243%, to estimate the price volatility, multiply the bond's modified duration by the expected adverse daily yield movement, and again that's going to be given in terms of basis points. So an important formula to remember: modified duration equals D over 1 plus R. D is the duration, and a zero coupon bonds have a duration that is equal to the maturity, and R is the yield. So now we're getting into a very important part of the video and the lesson that we're going to look at 5 practice questions, and that's how we're going to finish it up. And of course, this is going to be heavily tested on any midterm test and final. Okay, so this first practice question: Citibank has a 6-year zero coupon bonds with a total face value of 20 million. The current market yield on the bonds is 10%. What is the modified duration of these bonds? A, 5.45 years, B, 6 years, C, 6.6 years, D, 10 years, or E, 10.9 years. Okay, this question should be fairly easy. The modified duration of the bond, I've shown the formula here, equals D divided by 1 plus R. D is the duration, and recall that zero coupon bonds have a duration that is equal to the maturity. So here it says that it's 6-year zero coupon bonds, so we know the numerator is 6, and the denominator is 1 plus R, and R is the yield. It says the current market yield on the bonds is 10%. So modified duration, D over 1 plus R equals 6 divided by 1.1, and that gives us 5.4545. So if we just bring up the financial calculator very quickly, it's just easy. 6 divided by 1.1 equals 5.45455. So clearly the correct answer is A. We need to know how to calculate modified duration equals D over 1 plus R. Okay, the next practice question: Citibank has a 6-year zero coupon bonds, total face value of 20 million. Current market yield on the bonds is 10%. Now this question is, what is the price volatility if the maximum potential adverse move in yields is estimated at 20 basis points? A, negative 1.32%, B, negative 2%, C, negative 2.18%, D, negative 1.09%, or E, negative 1.2%. Okay, very good question. You can see where this is headed, where we're building it up. So the first part of the question is exactly the same as we've seen on the previous question. They're giving us a 6-year zero coupon bond, face value of 20 million, current market yield is 10%, but here they're asking for the price volatility. So remember, the daily price volatility is the product of the modified duration times by the adverse daily yield move. So they're giving us the adverse daily yield move at 20 basis points. So remember, that's going to equal 0.002. This is why it's important to understand our basis points. 100 basis points equals 1%, 20 basis points equals 0.002, okay? And you can see that all the answers are being given in a negative. So the adverse, they're assuming that it's a negative effect. So again, modified duration, this is from the previous question. This is why this is building up nicely. that equals D divided by 1 plus R. Well, we know the D is zero coupon bond. The duration equals the term, so it's a 6 year. So the numerator is the 6 divided by 1 plus R, which is the yield 10%, 1.1. So we saw that in the previous, this is a carry forward. We did the calculation on the previous question. The modified duration is 5.4545. So all we're doing to calculate the price volatility is we're multiplying that by the basis points, negative 0.0020. So if I bring up the calculator here, that's our 5.4545, and we're going to multiply it by 0.002, make that a negative. And just wanted to show you, we get the negative 0.00109, but it's giving us as negative 0.109%. So I recall, to make it a nice round number, we're just going to multiply it by 100. And there we've got the correct answer, negative 1.0909. So quite easy on that question. When we're calculating the price volatility, it's modified duration times the adverse daily yield move, modified duration D over 1 plus R. And the adverse yield, move in yield is going to be given in basis points. 20 basis points equals 0.002. Nice little question. For sure going to be heavily tested midterm and final. So another practice question. I think you can see where this is going. We're using the same data again at the beginning. Citibank has a 6-year zero coupon bond with a total face value of 20 million. Current market yield on the bonds is 10%. Now, though, it says, what is the daily value at risk, VAR, of this bond portfolio if the maximum potential adverse move in yields is estimated at 20 basis points? Is it at A, negative $246,111, B, negative $218,180, C, negative $135,474, D, negative $149,021, or is it E, negative $225,789? Okay, that's our final question with regards to this series of looking at this Citibank. And I did a bit of color coding in the solution here. This is the nice, perfect review slide. Okay, so Citibank has that 6-year zero coupon bonds, total face value of 20 million. Current market yield on the bonds is 10%. What is the maximum daily value at risk, VAR, of this bond portfolio if the maximum potential adverse move in yield is 20 basis points? So again, just moving how we're going to calculate for the solution. The value at risk is the dollar value of the position. That's market value. So we know that's going to be 20 million times by the price volatility. And we know that the price volatility is the product of the modified duration times by the adverse daily yield move. So again, we've calculated the modified duration. That hasn't changed. And I did some color coding here just to help our understanding. Modified duration is the duration divided by 1 plus R. And with a zero coupon bond, the duration is just equal to the term. So I put that here in pink. It's a 6-year zero coupon bond. So modified duration, D over 1 plus R. The numerator is 6. That's the D. And for the denominator, 1 plus R, that's the yield. The yield is 10%. I put that in green. So again, quick little review. Modified duration on this zero coupon bond equals 5.45455. Okay. The adverse daily yield is the 20 basis points. So we know that equals the 0.002. Okay. So that's the daily price volatility, MD times adverse daily yield. We calculated that before. That was the negative 1.09% or something like that. So now to calculate the value at risk in terms of the dollar value, it's just going to be the 20 million times 5.4545 times negative 0.002, and we're going to get negative 218,180. So let's just bring up the calculator on that. So we're going to have 20 million is the value, market value of the portfolio, times 5.4545, something like that, multiplied by 0.002, and that's a negative, and we're going to equal negative 218,182. Okay, so it's closest to B, negative 218,180. So again, value at risk, it's the dollar value of the position times by the modified duration times by basis points. Those are the variables that we're looking for, the three components. And recall that the product of modified duration times by the basis points, the sensitivity of the asset times by the shock, gives us our price volatility. Okay. So 2 more practice questions to finish this video, and you can see this practice question is going in a new direction. Recall we can calculate the daily value at risk, but we can also then calculate value at risk for a longer time period. And I'm going to show you how to do that when we look at the solution to this question. So the VAR of a bank's trading portfolio has been estimated at $5,000. It is assumed that the daily earnings are independently and normally distributed. So what is the 10-day VAR? Is it A, $5,000, B, $10,000, C, $15,811, D, $22,361, or finally E, $50,000? So you see that this question is actually fairly simple once you know the formula. To calculate the 10-day VAR, we just take the daily earnings at risk, which they've given it to us. The VAR of a bank's trading portfolio is assumed to be $5,000. That's daily, so daily earnings at risk is the 5,000, and we're just going to multiply it by the square root for the number of days. In this case, they're asking for the 10-day VAR, so it's the square root of 10 times 5,000. If they're asking for the 20-day VAR, it would just be the square root of 20. So if we just bring up the calculator, what we're going to do is 10, take the square root, multiply it by 5,000, and what we're going to get is 15,811. That is the correct number. So again, you can see that A is not going to be right, because if the daily earnings at risk is 5,000, if we're extending that for 10 days, the number obviously has to be more. And how do we do it? We just take the square root of n and multiply it by the daily amount. Okay, really easy question. Going to be tested on midterm and final for sure.